Our next speaker is Li Shi. He's from DDN and he's the development lead of Advanced Solution Laboratory at DDN. He has been working on Lustre and related issues almost close to 10 years. And Li.
Hello everyone, I'm Li Shi, and today I'd like to share the work that DDN has been working on. It is the policy engine. So we call the policy engine LIPE. So the first question is why we want to implement the policy engine. Well, the motivation is simple. We think that administrators don't have enough tools to do data management on Lustre. So, for example, myself, I write a lot of simple scripts to do data management from time to time, but I think that has obvious limitations because it is not easy to get good performance, and it is not easy to extract all of the Lustre attributes, which could be very useful for data management. And that's the motivation we want to implement a policy engine to solve at least part of the problems. And we implemented the LIPE policy engine in a way that it is optimized for Lustre. It will scan the LDXFS directly, so it can get very good performance, and it will understand Lustre very well because it is able to get almost all of the Lustre attributes from the disk. Well, some of the attributes are internal attributes of Lustre. For example, the stripe information, the HSM status, or link extended attributes, something like that. And we implemented the LIPE policy in a way that we think it should be very powerful and very flexible, so it can be used in a lot of use cases. So we think that LIPE could have some advantages because, well, first of all, it scans MDT directly. So this brings some advantage because the LIPE doesn't need to use extra server or storage for storing the metadata, and we don't need to duplicate the metadata for the LIPE, and we don't need to sync between Lustre metadata and the database or any other storage. And well, because usually the MDT are based on SSD, and the SSD is quick, so we usually can get quick scanning speed by scanning the MDT directly. And also, even if we are using DNE, now or in the future, the LIPE can scale up with DNE too because it can scan the MDT in parallel on multiple metadata services. And we need to define very precise rules in LIPE because we need to use the several arithmetic expressions for the rules. So this brings some advantages because we don't need to worry about the vagueness of the expression. The expression should be very precise and the meaning of it should be always the same. And even we need to upgrade the LIPE, the meaning of them will keep the same. And also, the LIPE policy engine is easy to set up. We only need to install a user space RPM, and we can start to using the GUI interface to configure the LIPE policy engine, and we can use that interface to configure the rules, to run the policies, and then to get the reports from the interface. And also, as soon as we install an LIPE system, we can use that system to manage multiple file systems of Lustre. So this graph shows the framework of LIPE. So we have a GUI interface for the users. The users can configure the policy rules in the website, and then the configuration will be sent to the policy engine. So the policy engine will use the configuration to scan the entities and even OSTs in parallel, and the matched files will be sent to the policy engine, and the policy engine will use several agents to handle the file lists. Well, the policy engine agent will handle these actions. These actions including a lot of data management actions. For example, we can remove the matched files, we can archive the matched files, or we can move the files between different storage. And also we can do some cache management according to the action types. So as we have mentioned, we need to define a lot of expressions of rules. So an expression is a arithmetical expression. It is in the form of Polish notation, and it has a value of assigned 64-bit integer. And in the expression, we can use a lot of kinds of operators. For example, arithmetic operator, relational and logical operators, and bitwise operators. Well, generally, all of the operators that is supported in C language can be used in the LIPE policy engine. And also, we can, of course, use assigned 64-bit integer in the expression. And also we can use constants in the expression too. Another thing we can use the expression is the system attribute. An example of the system attribute is, for example, the data type, or the free inode number of the system, or the free disk space of the file system. Also, we can use object attribute in the expression. The object attribute means the attribute values of the files. For example, the access time, modify time, and other timestamps, size, or the UID, GID, and all of the other kinds of attributes we can get from the file. And another thing we can define in the expression is we can use the function. So a function is a special. It can do special things. For example, it can, for example, the f name. This action can match the entry name of the file to a regular expression. And another example is OST function. The OST function will will check whether the file locates on the OST or not. If the file locates on that OST, then the value will be 1. If the file doesn't locate on that OST, the value will be 0. So on the bottom of this page, there is an example. So this example shows what expression is. And this expression means that that this inode should be a regular file, and at the same time, this file should have access time which is earlier than the which is 1 earlier than the system time. Okay, so that's the meaning of this expression, and we need to define a lot of expressions like this. And in each rule, we can define one action for the rule. The simplest action would be the counter increase. Well, it will simply increase the counter. And other kinds of actions are remove the file, or archive the file, or restore the file, something like that. And we can also use other kinds of actions like set the project ID of the file, or run an L-advise action on the file. And as soon as we define multiple rules, we can group these rules into different groups for different purposes. For example, we can define a rule group to summarize the size distribution, and we can define another rule group to summarize the access time distribution. And also we can, for example, to define a rule group for the HSM actions. And this graph shows how the values are evaluated in LIPE policy engine. So as we can see from this graph, we have multiple rule groups, and each rule group have multiple rules. If we match the first rule, then the other rules in the group will be skipped, because it is already been matched by the first rule. And if the first rule is not matched, then it will go on to the second rule. And if the second rule is matched, then the third rule will skip. And if all of the rules in one group is not matched, then no action will be taken for this rule group. So this is how the LIPE policy engine evaluates the rule groups. So LIPE are composed by several components. For example, the LIPE web. This is a GUI interface for the administrator to configure the system, to run the policies, or to get the reports. And we have LIPE command. This command can scan the MDT and prints a lot of file lists for different rules. And we have a command LIPE file list handle, which will scan the matched file list and handle all of the actions for this file list. And also we have a LIPE launch command. Well, this command will do all of this process. I mean, it will scan the MDTs, it will apply the actions on the file list, and finally generate the reports according to the action results. And also we have agent manager, which will manage the HSM copy tool for the system. And we have other HSM tools to do other kind of tasks for the HSM management. So this is the GUI of LIPE. And on the left side is the navigation of it, and we can select in the navigation, and in the left side it will print the contents. So on the top of it we have a control table, and in the control table, if we press a button, we can edit the rules or the expression or the rule groups, and we can delete anything, or we can add anything, we can change the order of the arrays, and when we are changing the expression or other things in the graph in the website, the tool tips will be shown, and you can get some tips on how to configure it. So this is another example. This is a result that LIPE prints. So we can select historical results, and we can get some statistical charts from this graph. And as we can see, we have two groups in this graph, and we have type distribution and access time distribution. And in the access time distribution, we can find a pie chart which shows the access time distributions of all of the system. And if we print, if we select item in the pie chart, we can download the file list, so we can add it in the future. For example, to check whether a file is inside the file list or not, or we can use an external tool to handle the file list. So of course we have got some problems when we are implementing the policy engine. The first problem is that the MDT doesn't have the file size saved on the disk. So that means if we define a rule with the expression with the file size, we are not able to get the correct value or the desired value. And the solution is we can implement a file size on MDT. And well, there have been some discussion about this, and I think maybe we could implement a lazy file size on MDT, and that should be enough for the policy engine to use. And that means we don't need to sync the file size between OSTs and MDT all the time. We only need to update the file size. For example, when the file is closed or when the file size is out of sync for maybe 5 seconds. And this brings some advantage. First of all, we can avoid the cost of implementing a very strong guarantee file size. And at the same time, we can satisfy a lot of use cases, because most of the use cases, I don't think it is necessary to provide strong guarantee of file size on MDT, because anyway, we can check the file size on client if we need, right? And another thing is that we currently don't have the policy of removing the archive on last unlink. Well, this means that, as we know, if a file already have archived data on the HSM storage, when we are removing that file on Lustre, we need to remove the archived data, right? But currently, the current policy doesn't do that. The current policy, well, we need to scan the Lustre changelog to make sure if that happens, the policy engine will remove the archived data by itself. So that's why we implement some workarounds. We use the HSM removal tool to watch the changelog, and if something happened, I mean, if the unlinking of files happened, then the policy engine, the tool will remove the archived data from the HSM storage. And also, well, we need a HSM check tool to scan the HSM storage from time to time to make sure we can clean up all the garbage in the HSM storage. But the correct solution, the final solution, I think, is the patch from Bruno in Intel. And I think the patch will be merged soon, so this problem should be fixed or in the near future. So another problem is that, well, the LIPE currently always do the full scanning of the MDT. Well, sometimes it's fine, but it is still not efficient if we want to scan repeatedly and in a short interval. So that means we need to implement the incremental scanning. And that scanning should be based on changelog. And well, the design is simple. For example, we already have the file list from the last round. We can check the changelog and scan and filter all the files which has been changed. So they will no longer match the rules in the file list, and we can get rid of these files from the file list. And at the same time, some files might have been changed so they match the rules. So we combine these two file lists and generate a new file list. So this is the design of the incremental scanning. So the use case of LIPE, obviously we want to use it on HSM. And LIPE should be able to manage the whole process of HSM. And we have customers who are collaborating with us, and they are going to use LIPE for HSM management. And I think we can get feedback very soon. And another use case is to use LIPE for file system report. And well, we currently, in general, we have a report which includes statistical charts based on the percentage. Well, the percentage could be based on disk usage, and it also could be based on the inode numbers of the matched file list. And at the same time, as we already know, we can download the file size from the website or from the server for further check. We can use other tools to check the file list and to take actions on these files. And also we can sort the file list according to the UID or GID or the files. Well, sometimes the customers wants to know the files with the largest file size, for example. So that's why we are going to implement that. And also we can provide a .docx format, I mean the Word format report for the results of the scanning. And well, in this way, the administrator only need to get a report, a summary report of what they really cares about. Okay, we did some benchmarks on the LIPE policy engine, and the test system is really simple. We use SSD for the MDT, and we scan the MDT to check the speed of the scanning. So if we can cache the metadata, all of them in the memory, then the speed is really good. It's 59 million inode per second, and the CPU is a limitation in this case. And if the memory is not large enough, we need to read from the SSD, and in that case we can get 1.8 million inodes per second, and obviously the bottleneck will be the disk speed. And but I think maybe on the production system we cannot, we might need to limit the scanning speed, because well, if the scanning speed is too quick, we need to avoid the scanning will impact the Lustre service. So that's we might need to do in the future also. So as Andreas has mentioned earlier today, I think Lustre has a lot of potentials on the data management field. So I think, well, maybe in the future we can use LIPE for other data management tools, other data management tasks. So that's why I think we have a lot of potentials. Well, of course, the first thing we want to implement is to add ZFS support, because well, sometimes we have MDT with ZFS. And another thing we can do with LIPE is that we can combine it with LAdvice. LAdvice is a tool or API that we can give file access advice to the server. So if we combine LIPE with LAdvice, we can apply the policy and define policies for the LAdvice, and the policy engine will send the LAdvice automatically. So another thing is that we can combine LIPE with Loris. Well, Loris is a tool that DDN has been developing for the backup of MDT. As we have introduced, the scanning of LIPE could generate a lot of pressure to the MDS, and since the Loris has backed up the MDT to external storage, that means we don't need to scan the MDT. We can scan the backup directly, and that will reduce the pressure to the Lustre file system. And as far as we have tested, the scanning speed should be similar, should be almost the same to the results that we scanned directly on MDT. Also another potential is that we can combine LIPE with L2RC. L2RC is a cache level that we have developed for Lustre on the ST side. And of course, we can replace L2RC to other kinds of cache level, and we use LIPE to manage the cache prefetch and the shrink of the cache level, right? And another potential is that we combine LIPE with file heat. File heat is a value that can reflect the access frequency of the data. And if we use LIPE to scan the scan the OST, we can get the file heat of the OST objects, and we can do data management according to the file heat. And also, another thing we want to do is to combine LIPE with a tool named MPI file utilities. Well, this utility is a group of MPI-based tools which can do the data copy or data mover or work of the directory really quickly. So if we combine these tools together, we might be able to scan POSIX file system instead of Lustre, so we can have general support for the file systems. Okay, as a conclusion, we implement a new policy engine for Lustre. Well, we call it LIPE, and the LIPE can scan the MDT or SDs directly, so it requires no external storage. And as far as we have tested, LIPE has quick scanning speed. And of course, we hope that LIPE could have a lot of potential use cases in the future, including HSM. Okay, that's all. Thanks. So any questions?
Is this open source?
Well, if we are changing anything in Lustre, we'll of course push to the Lustre community. But I think the company will require me to keep it internal for some time at least.
You were talking about that it works for multiple MDTs. How are the results combined? So, for example, you showed an example of incrementing a counter. So if I had 4 MDTs and I run the policy on all 4, how do you get the single result from that?
Well, we have a process which can combine. Well, first of all, we need to scan the MDT in parallel on all of the MDTs, and we get several file lists, a series of file lists, and we have a process to combine these file lists anyway. So even we have multiple MDTs, that's fine. We can combine these file lists to a single file list and then do actions to these file lists.
So you mentioned the problem of the file size on the MDT. Do you have a plan to get size on MDT working, even if it's a lazy size like you talked about?
Currently, we need to get the file size from client directly. And that means we need to, first of all, we need to scan the MDT to get a filtered file list, right? And as soon as we get the file list, we need to check the file list again, to check the file size again on the client side. So that's a workaround. Because since we are checking it on the client side, the speed will be slow. So we really want file size or MDT to be implemented in the near future, so we can use that and speed up the scanning speed of file size. And we don't need that process anymore. To get the file size on client side.
How many threads are you using to scan the MDTs, and what kind of load is that putting on them?
Well, currently we are using, it's tunable. We can change the thread number according to the result. If we want to check the stress, it's just change the argument. That's fine. And currently we are using 8 stress by default, and we didn't check. Well, maybe if there are more CPUs and speed of the MDT is quicker, we may use more stress. But with 8 stress, that's pretty enough.
I saw in one of your earlier examples that you specified via file name. I'm curious whether you allow rules to be specified via path for, say, an entire subdirectory.
Excuse me, please.
So I saw you showed an example of, I believe, like a direct file name to trigger a rule. I was curious whether you had the ability to specify a subdirectory that you wanted, all the files beneath a certain subdirectory to be triggering rules.
Well, currently we don't have the directory tree, so we kind of split all of the inodes without the directory tree architecture. I mean, so that means we can only get a file list of individual files instead of, for example, a subdirectory, and the files on this subdirectory all matches the file. So we only get separate files in a file list.
That makes sense. Thank you.
Okay.
Any other questions? Okay, we are officially on break. See you in 20 minutes at 3:20.